All right, day 2 of Unit 8. We've been talking a lot about the Pythagorean theorem, and we're going to talk about something called the converse of the Pythagorean theorem. That just means if I know that a squared plus b squared equals c squared in a right triangle, at the same time I can say that if a squared plus b squared equals c squared, those three sides have to make a right triangle. And we'll get to that in a minute. First, I just want to remind you yet again, whenever we use the Pythagorean theorem, you got to be really careful about which side you put C on. Again, A and B kind of don't matter. C does matter. And I know you're getting sick of hearing this, but C is always the side across from the right angle. In other words, C is always the hypotenuse. And that doesn't matter how the triangle is sort of turned. Wherever the right angle is, go across from that, or find the side that doesn't touch the right angle, make that C, and then you can make this A and this B, or I could say this is B and this is A. Those two don't really matter. The one that matters always is C. Okay, so even if I'm over on this triangle here at the right, find the right angle, go across from it, make that C. That's always got to be step number one. And then the other two sides I can make A and B, or B and A. Which one B and A, which side I put B on and which side I put A on, that does not matter, but it always matters where I put C. Okay. The other thing you have to be able to do is tell the difference between a right triangle, an acute triangle, and an obtuse triangle. Okay. A right triangle, obviously, is just a triangle that has a right angle in it. So if I go through these three triangles right here, if I want to know which one's a right triangle, I just find the one with a right angle. Obviously, it's this one in the middle. So that one is going to be my right triangle. Okay, an acute triangle. Remember, acute means an angle less than 90 degrees. So acute triangles are triangles that have all three angles less than 90 degrees. Right? Triangle in which all three angles are less than 90 degrees. That's going to be this one over here on the left, right? I can look and see all three of those angles are less than what they would be if they were 90 degrees, right? If I look at this one down here, if it was 90, that's not a straight line. If that angle was 90, the other side would have to be something like this green line that I've drawn right there. But since it's smaller than that, that's not 90. This angle right here, if I wanted it to be 90, the other side would have to be something like this, but it's less than that, so that one's less than 90. Same thing down here, and so this triangle all the way on the left, that's my acute triangle. Obviously, then that leaves this triangle on the right to be the obtuse triangle. Here's why that is. An obtuse triangle is a triangle with at least one angle greater than 90 degrees, more than 90 degrees. And so we can kind of see that it's going to be this one in the lower left, better or bigger than 90 degrees. How do I know? The easiest thing to do is take a corner of a piece of paper or something, line it up with this. The corner of the piece of paper would go straight up like that if this was exactly a right angle, but it's bigger than that. That means that this angle in the lower left-hand corner is obtuse, is greater than 90 degrees. And so whenever you have a triangle with an angle that's bigger or greater than 90 degrees, it's an obtuse triangle. Okay, the first piece of new information for day 2 of Unit 8, something called the Pythagorean triple. Right, so triple means 3. So what we're dealing with, if you have a Pythagorean triple, it just means 3 numbers, such as 3, 4, and 5, that we know will work if we plug it into the Pythagorean theorem. In other words, I know that if I take the two shorter sides, 3 and 4, and I square both of those, they'll give me 5 squared, right? So this would be like a squared plus b squared equals c squared, right? The longest side would be the hypotenuse, okay? Same thing with 5, 12, and 13. If I take the two shorter sides, so in this case 5 and 12, square both of those, they're going to add up to the longer side squared, right? 5 squared would be 25, 12 squared would be 144, 13 squared is 169, and so you can take my word for it or you can check me on a calculator, but 25 plus 144 is indeed 169. So what these numbers are, what these triples, what these sets of three numbers are at the top, are numbers that we know will work, will come out evenly if we plug them into the right spot in the Pythagorean theorem. So there are the four at the top, 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. But we also know that if I multiply these three numbers by the same number, so like if I did, let's say I did 3 times 3, 4 times 3, and 5 times 3. Right, so I did 3 times 3, and I square that. And I did 4 times 3, and I square that. It's going to give me whatever 5 times 3 squared is. Well, 3 times 3 is 9. So 9 squared plus 4 times 3 is 12. So 12 squared. 3 times 5 or 5 times 3 is 15. And that's what I have right here. We also know that's going to work out. All right, 9 squared is 81. 12 squared is 144. Just to be sure, 15 squared is 225. Is 81 plus 144 225? Let's make sure. It is. So any number that I choose can be 3 like I did here. It can be 100. If I multiply any of these three Pythagorean triples in the top row here by the same number, it's going to give me another Pythagorean triple. Right? I could do the same thing again with 3, 4, and 5. I could multiply them by 10. If I multiply 3, 4, and 5 all by 10, 3 times 10 is 30, 4 times 10 is 40, 5 times 10 is 50. That's going to work out too. Let's test it. 30 squared is 900. 40 squared, 1600. And 50 squared is 2500. Does 900 plus 1600 equal 2500? It does. Again, you could multiply these three numbers in the top gray row by anything. As long as you multiply all three of them by the same number, you'll get another Pythagorean triple. So why does it matter that there are these combinations that are Pythagorean triples? Well, sometimes it's going to be a shortcut for you when you're doing a problem with right triangles, and you'll see what kind of problem that would be later on. Okay, this is the part of the lesson that actually speaks to the title of this part of the chapter, the converse of the Pythagorean theorem. It's just sort of saying like the other side of the coin of the Pythagorean theorem. So what we know from the Pythagorean theorem is that if I have a right triangle, here, this side squared plus this side squared would give me that side squared. The converse says, maybe I don't know yet if I have a right triangle, right? Let's say I have a different triangle here, and it looks something like this. And I want to know, is this a right triangle? The converse of the Pythagorean theorem says that if I can square this number and square this number and add those two together, so if a squared plus b squared, if it equals c squared, then I know I have a right triangle. So what that allows you to do basically is plug numbers in, and I have a couple of examples here that we'll do, to see whether those three sides could possibly make a right triangle or not. Okay, so the two shorter sides have to go together as a and b, and then the longer side's the hypotenuse if it's a right triangle. So let's test out 6, 10, and 14. So 6 squared plus 10 squared. If this is a right triangle, that would equal 14 squared, right? Is 6 squared plus 10 squared equal to 14 squared? Well, it's pretty easy to check. 6 squared I know is 36. 10 squared I already know is 100. 14 squared is 196. You can probably see that 36 and 100 is not going to add up to 196. So no, those three numbers, if I have a triangle with side lengths of 6, 10, and 14, it cannot possibly make a right triangle. Okay. If I move over here and I do 9, 12, and 15, does 9 squared plus 12 squared equal 15 squared? 9 squared is 81, 12 squared is 144, 15 squared is 225. Does 81 plus 144 equal 225? Yes, it does. So this set of numbers here is a Pythagorean triple. In other words, if I have a triangle and its side lengths are 9, 12, and 15, I have a right triangle. Okay, so for the ones that don't work, right, when I take a squared plus b squared and it doesn't equal c squared, I can use what I find there to decide whether the triangle that I have with those sides is acute or obtuse. And here's how that works. If I add a squared and b squared together and I get something bigger than c squared, right? If the two smaller sides squared and added together are something bigger than c squared, I have an acute triangle. If I add a squared and b squared and I get something less than c squared, then I have an obtuse triangle. So here's how I would do a problem like this. Find the two shorter ones. So I'm looking at 3, 6, and 9 here. Two shorter ones are 3 and 6. So I'm going to have 3 squared plus 6 squared. And then over here I'm going to have 9 squared. And I don't know yet. I don't know what symbol I'm going to put in here yet. I don't know until I actually use the calculator to figure out what these are. I don't know if this is going to be equal to, greater than, or less than. So let's figure that out. 3 squared is 9. Actually, I don't even need a calculator for this one. 3 squared is 9. 6 squared is 36. 9 squared is 81. So 9 and 36 is 45. So I end up with a situation where I have 45 here and 81 here. Well, 45 is obviously less than 81. And so in this case, what I have is my a squared plus b squared is less than c squared. So I come back up here. When c squared is bigger than the other two put together, this triangle is obtuse. Right? C squared bigger than a squared plus b squared. I have c squared on the other side up here than I do down here, but it still works. So that would be an obtuse triangle, and that would be a triangle looks something like this, where it has at least, well, only one angle that's bigger than 90 degrees. All right, now let's try 8, 9, and 11. So I find the two shorter ones, 8 and 9, and then I put 11 squared over here kind of by itself. And again, I don't know yet what kind of symbol I'm going to put in between them. I have to figure that out. 8 squared is 64. 9 squared is 81. 11 squared is 121. And so 64 and 81 is going to be 145. Over here I just have 121 still. This time a squared plus b squared turns out to be bigger than c squared. And so if I come back up to the table up here, what happens when the two numbers added together, squared and added together, are larger than the third number? That's one like this. So I have an acute triangle now. This one is going to be an acute triangle. So again, if I have a triangle and its sides are 8, 9, and 11, that means that has to be an acute triangle. An acute triangle is one like this where all three angles are smaller than 90 degrees. All right, now I'll do a couple of examples that should help you on your homework. These first two I probably don't even need to do because hopefully by now you're experts at the Pythagorean theorem, but I'm going to do one just in case, and then I'll let you do the other one. Okay, I'm going to do number 1. First thing I always tell you have to do is figure out which side would be C, right? It's tempting to always think that the side with a variable is C, but that's not going to be true, right? C is always the side opposite of, or that doesn't touch the right angle. So in this case, our C is going to be 13, and we can say that X is A and B is 5. So now we just plug in what we know in the order that it is supposed to come in. So X squared plus 5 squared would be equal to 13 squared. So x squared plus 25 is going to equal 13 squared, which is 169. Subtract 25 from both sides because I want to get x squared by itself. Those go away. X squared equals 144. Now is when I take the square root of both sides, and the square root of x squared is just x. The square root of 144 ends up being 12. Right? So this side down here that we were calling x is 12. Okay, I'm going to let you do 2 on your own. I don't think you need any more guidance from me on this. But make sure that you figure out which side is C. Make sure that you use x as your C in that problem because it's the one that's across from the right angle. Okay, this is one where I'm going to set up the equation, but it's not actually going to be an equation because I'm not sure yet whether these 3 sides can form a right triangle or not. So what I have to do is test it, right? So I find the 2 shorter sides, and in this case that's going to be 11 and 60, and I put those 2 together, and I see what happens if I square both of those and add them together. How is that different from the big side squared by itself? Right? I'm comparing these to see what happens. So I have 11 squared, that's going to be 121. I want to make sure I get 60 squared correct, so I'm going to use my calculator. It's 3,600. And then I'm going to square 61 over here by itself, and that's 3721. Okay, what is 3,600 plus 121? Oh, it's 3721, and that's what I have over here. So what does that mean? Well, these 2 are equal. If I have 3 side lengths that I can plug into the Pythagorean theorem and get an equation rather than an inequality, that means we have a right triangle. So if I have a triangle and its side lengths are 11, 60, and 61, I'm going to have a right triangle. So it turned out on this one that my 2 were exactly equal to each other, but if I would have added the 2 shorter sides together after they'd been squared and come up with something less than what I got on the other side. In other words, if somehow 3,600 plus 121 was less than 3721, that would mean I had an obtuse triangle. If, on the other hand, I add these 2 together and they end up being larger than the single number squared, then I would have had an acute number. But because these 2 are exactly equal to each other, it means that if I have a triangle with sides of 11, 60, and 61, it's a right triangle. All right, this one, I took a minute and I wrote down the steps on this one. It seems simple, but pause the video once I'm done explaining this problem and write down these steps. You can do it in your own words if you want to. I just want you to have these steps down. This problem seems simpler than it turns out to be. Okay, it says use a Pythagorean triple to find x, and then we're not going to bother with explaining your reasoning on this one because I just want to know that you know how to do it. So we're going to use a Pythagorean triple to find x. What that means is that rather than using a squared plus b squared equals c squared to find this, it wants me to use that table of Pythagorean triples from a little bit ago. Okay, so here's how we have to do that. Again, pause the video now if you haven't already, and write down steps 1 through 5. Okay. First thing I got to do is take the 2 sides that I know, in this case 35 and 21, and find the lowest common denominator. Right? That's what LCD means here. Lowest common denominator between 21 and 35, other than 1, obviously. So does 2 go into both of them? No. Does 3? No. Does 4? No. Does 5? Goes into 35 but not 21, so no. Does 6? No. Does 7? As someone who follows football, 21 and 35 stand out to me because those are like football scores. So I know that 7 is the lowest common denominator of those 2, so I'm going to write that down. The lowest common denominator of 21 and 35 is 7. Next step, divide both numbers that I know by that lowest common denominator. So in other words, 21 divided by 7 is 3, and 35 divided by 7 is 5. So there's a number x here that I don't know that I'm going to put in the middle. Why am I putting it in the middle? Well, it's because I know that x has to be somewhere, it can't be longer than 35, right? Can't be longer than 35. It may or may not be bigger than 21, but it can't be larger than 35. So I'm going to put it second. Okay, so I'm going to take this 3 something 5. I'm going to go back to this chart here, and I'm going to look for which Pythagorean triple it probably is. Well, obviously it's going to be this one right here, the 3, 4, 5. That means my missing piece is a 4, but that's not how long that side is, right? I just know that if I took that side and divided it by 7, I would get 4. So the Pythagorean triple I'm working with is 3, 4, 5. The one I'm missing is 4, right? That's the one that was x up here. So now to figure out what x up here actually is, in other words, how long that side is, I'm going to multiply this missing number by the lowest common denominator, which I found up here. So I'm going to have 4 times 7, which is 28. So x here would be 28. All right, last example before you'll be ready to work on the problems. Okay, example 5. Okay, it says determine the type of triangle when given coordinates. So when it says the type of triangle, it means, is it a right triangle, is it acute, or is it obtuse? Okay, so let's plot the points first. -7, -3, so x always comes first, so I start by going back 7 and down 3. So there's one of my points. -2, -5, so I go back to down 5. -4, -1, so -4, -1. Okay. So here are the 3 points of my triangle. I'm going to connect them with lines. That's going to help me see something here in a second. All right, there's the triangle. It wants to know, is that a right triangle, an acute triangle, or an obtuse triangle? So it looks like, when I first look at it, it looks like maybe that's a right angle, but I can't be sure. Here's something I'm going to say to you, and I'm sure I'm going to have to say it to some of you again. Don't just assume that because it looks like a right triangle that it necessarily is. We have to check. A right triangle is a 90 degree, has a 90 degree angle. And so basically what I'm doing on this problem is I'm checking to see, is this angle right here indeed 90 degrees? The only way to check without getting out a protractor is to see if the slope of this side of the triangle is perpendicular to that side of the triangle. So what I have to do is I have to find the slope of both the yellow and the green line. It's not as hard as you think, especially since we have a graph right here. What happens when I go from this point to this point? Well, I have to go up 2 and right 3. So that just means the slope of that yellow line is 2/3, right? Rise over the run. All right, if the green line is perpendicular to the yellow line, then its slope, the green line slope, is going to be the negative reciprocal of 2/3. That's that thing where we take a fraction and we flip it, and then we change its sign. So the only way this is a right angle is if this green line has a slope of -3/2. Well, let's look and see if it does. If I start at this line, how do I get down here? Well, I have to go down 4 over 2. Down 4 over 2. Well, obviously, that is not equal to that. So, it's not a right triangle. Okay, so we can say, is it a right triangle? No, because this angle right here, the only one that looks like it could possibly be a right angle, we just figured out, is not, because the slope of the green and yellow lines are not negative reciprocals. Well, what would it look like if the green line was at a 90 degree angle to the yellow line? In other words, what if, instead of being this green line right here, what if that side of the triangle had a slope of -3/2? Where would it be? Well, if I went from this point down 3 over 2, that side of the triangle would have to pass through that point. In other words, the line would be doing this. The reason I'm doing that is because that helps me see whether this angle is acute or obtuse. If it's less than 90 degrees, I have an acute triangle. If this angle is greater than 90 degrees, I have an obtuse triangle. Well, since the side actually makes a smaller than 90 degree angle, this angle is acute. This angle, I can just see by looking, is less than 90 degrees, so that angle is acute, and this one also is acute. And so this triangle is acute.